So yeah, I had an interesting time grading all those homeworks last night, and sorry to those of you who I had to send a grade and then send an updated grade that was lower. um, so um, because one of the problems I wasn't looking at closely enough, and this took a correct answer for an incorrect one. Um, so, uh, but you have the opportunity to uh, uh, fix things up. Whether you want to do that either before or after the test. Okay, so um, so there are two problems in particular from that assignment that are worth discussing. Um, the first one, actually, even though I'm going out of order within the book, number 19. Wait, need to go back to the problem itself. Um, okay. Um, Problem 19 does not involve actually computing a Fourier series at all. You're not evaluating the integrals. You can if you want, but this is about how Fourier series converge. What do they converge to? And how that relates to the behavior of a function. Whether it's continuous or not continuous. It's all about that. So in fact, number 19 is a short answer, emphasis on short uh, problem. And there will be one like this in the test where you have to understand whether the Fourier series converges to the function that it's representing, or if it does not converge to that, what does it converge to? Um, so, um, and that would go to, let's see. Well, there are certain theorems about this that you would just apply. Okay, so okay, theorems 122 and 128 talk about this, so you can apply those theorems to answer the question. Okay, so let me write it down. So 1.28. Okay. Now, so those theorems you should definitely keep in mind for the midterm.
I'm getting a sense of memorizing them and recite them verbatim. It wouldn't be a bad idea.
Not the one that just says it converges. It's not discontinuity. Then it's the 205
Yes. So, in other words, you wouldn't need to go to the trouble of memorizing the statement because I'm not going to ask you to state the theorem anyway. But if you do memorize the gist of them, as Vivian eloquently stated, then that would be enough for this. Okay, the other problem I want to mention is on 1.18 about the convolution, showing what the Fourier transform of the convolution is, how it turns out to be the component-wise product of all the Fourier coefficients of the two functions f and g that you're taking a convolution of. And because what's supposed to happen is when you look at the convolution, something like this, it may not be written exactly like this, but this is a convolution of f and g, and you're replacing each of these with its Fourier series, in this case a complex Fourier series, and you need to use a different index. Okay, so you use a m and n. Okay, then I can actually be t minus x. Okay, and what's very important here is so you're going to have terms involving all the each alpha times any of the betas. You have too many terms to start off with, and you have to figure out, well, how do you, because all this boils down to is a single sum of alpha n times beta n. How do those other terms go away? And yes, Sabagi, what you sent me right before class is good. So yeah, so you showed the right approach in that problem. Actually, I don't want to have another situation like yesterday, so I'm going to look again because I just took a minute to what is this? And okay. Okay, it's a different problem. Okay. Well, yeah, there's the double sum, and yes. Okay. So, the other thing I want to mention is, especially because I know that there's clusters of you, or maybe a large group of you that work together in these things, which is kind of a convenience for grading, but one problem in particular, it was the one. Showing that if f of x is even, then the Fourier coefficients are real, and if it's odd, they're purely imaginary. And in most cases, I end up giving credit, but it's kind of borderline because how you're presenting a solution really needs to be more clear, just as a whole, for the class as a whole. Because the way these things are being written, it's actually kind of difficult for me to really figure out, do you really understand what you're writing? Do you really understand why this is true? And that can be more difficult to tell if you're glossing over certain details. I need more details. And if you're not able to, and maybe it might be preferable to rely more on equations and less on words. When you're describing what's going on in words, it's easy to get yourself into trouble and end up making an incorrect statement. And besides, if you're not able to really make those steps, then you're showing me that you really don't understand. And I'm telling you this now because based on what I saw in this last assignment, I try to give credit where I can. But I may need to crack down on this more if I feel like you guys are not convincing me that you're getting it. Because it's something I really want to be sure about. So, and I realize that English is not the first language for everyone in this room. Although I found that even for some who it is the first language, this can still be a problem. So, because it's really about the math, not the language. Does each statement really follow from what you said before? In most cases, you really can do a lot more using equations and words. And I think that can be a way to more easily convince me that you understand the material. And I'm also telling you this because this applies to your other classes where the professor may be more strict about these things, especially classes that are more heavily proof-based than this one is, like 641.
You were thinking of that too.
Yes, that one especially.
Yeah.
So that's something to keep in mind, that the exposition of these things matters. And yes, because I hate grading, I tend to look at these things very quickly. But as I kept going through these assignments, I'm looking at the same problem and multiple versions of it. Each explanation was a little different, so that's good. That it's not, even if you guys are working together, that you're writing it up independently, and that's good. One thing I worry about are situations where if you're working in a group, I mean, that could be a very positive thing, but it can also backfire, because what if at the end of the day, say you have a group of 5 of you who are working together, and only 2 of them really understand the problem. That is not a good thing. So.
Well, I can assure you that everyone that works in my group understands the problem equally.
Okay.
Same, 'cause I ain't got a group. Just me. It's not
Okay.
live.
For every action.
And he's getting smart. He's starting to like try to write on the paper. I had to erase some marks off my paper.
Oh, wait,
My
what?
son, he's starting to write with pencil.
Oh.
So he tried to help with the homework.
Okay.
It's the fault of the
Okay. So that's your group, huh?
That's my group.
Okay.
Well,
He may
So,
be, you never know.
I do have to say, the most depressing thing about the beginning of this lecture is it's reminding me of something I said earlier tonight.
Oh, okay.
That is not
but
the
you
kind
said-
of reflection of my own mathematics. I don't.
Oh, but you said to your own class, or?
Yeah, not the group thing.
Oh, okay.
But,
Yeah.
Try and understand the material.
Yeah. Well, the thing is,
had a
So,
tail
yeah.
between my legs.
because that's just it. When the writing gets sloppy, it's hard for me to tell whether you understand it materially or not. You might, and it just so like, and you're just not expressing yourself well, or maybe you don't, and so
I'm sorry.
There's a certain lack of eye contact right here.
Do you
So I'm
hear
getting
that?
certain suggestions.
Yeah.
well, actually, it wasn't referring to you anyway. Okay.
Well,
I was laughing for when it was undergrad. It was like when Lynn and Teresa were also here. There was that one weird L, and it looked just a little bit different on everybody's paper. And he was like, "What is this?"
Oh, what was that? I don't remember.
I think maybe it was Laplacian. I don't know.
Oh,
No,
Lagrange
I don't remember.
polynomials or something.
Maybe that's what it was.
Yeah.
But yeah.
Yeah. So, that class was just awful in terms of, yeah, that was like 3 years ago.
Yeah.
Yeah. In terms of, but just working together having a negative consequence.
Yes.
Yeah.
Yeah. Exactly.
Okay. Yeah. So try not to have that happen again. But, okay. So those are the main things I wanted to get across about this particular assignment. So the exams have all been printed. I just need to track down Dr. Zhu. I could not find it this morning, but to get the test to him.
I'll take him too.
That's funny.
Don't feel bad. We gotta try.
Don't feel bad, we have trouble tracking data.
Okay. Yeah. Well, things that I told him that I'd give it to him on Tuesday, but they have to be ready today. But he teaches Monday, Wednesday, so we'll see how it goes. What?
Does he?
Uh,
Because he got rid of our Monday class, I figured he did that for this other one.
Oh, I have no idea about that. It's probably easier to do the graduate class. But, well, how many people are in your class?
There were 7.
Five.
There were 7.
See.
Okay. Well, okay. But again, if it's an undergrad class, it's a lot bigger. So good luck making that happen. Yeah, because we're in there for like 3 hours or something, or for 2 hours, like 2 hours and 25 minutes.
It's over 2, I can't.
Okay, like 12:30 to.
It's gotta be 3 hours, right?
Yeah.
Hour and a half classes now.
It's supposed to.
Yeah.
Yeah.
Okay.
I
Yeah.
don't even want to teach. I mean, I teach for 3 hours straight, and that's rough.
Yeah.
At least it's the same lecture twice.
Yeah, 3 hours with the same lecture twice really is a lot of fun because it's like you have a dress rehearsal for the first time, and the second class gets the real deal.
Yeah. When I did that long ago, I always felt I felt bad for my morning class because my afternoon class got a much better lecture, and it was also much faster.
Yeah. Well, I don't feel sorry for my morning class. The afternoon class sleeps through the whole thing. So.
Okay. It gets late afternoon. So what I want to get through today is since I have no notes, no 4 pages to get
Can
through.
we ask?
What?
Like, can we ask a question?
Yeah, but this is for you guys now. Do you have questions about either homework 3 or any of the problems or examples that I listed last time, but I said I used to to draw inspiration for my exam questions.
Can you do one similar to 1.19 of how you would want that worded of it converging? You can use different discontinuities. You can use whatever for.
Okay.
Or a different problem, but.
Okay.
I mean, is it just straight up saying like the Fourier series converges to f of x except for at these 2 points because these 2 points are discontinuous? So then just say.
Yeah, like okay. For instance, let's say fx equals x cubed on -1 to 1. So what we have here is this is how the graph looks on -1 to 1. So then imagine extending that to the left and right with a period of 2. So you get something like this. So what you can say is, so capital F of x is the Fourier. Whoops. There's now only one person who needs this video instead of two. But yeah. So the Fourier. Yeah. So I apologize for all those times where I forget to nudge the computer when you're watching. So,
Yeah. I have a note.
okay. So you can say that it's equal to a function itself for x between -1 and 1, excluding the endpoints, because the 2 periodic extension is continuous in the interior of the interval. So there's a jump discontinuity at ±1. So at x equal to ±1, can anyone tell me what the Fourier series will converge to?
2 times f of x. Oh, hold on. F of. I know it's on both sides, but how do you word that? I know it's divided by 2.
Yeah.
F of -1 plus f of 1.
Yes.
Oh, well. I'm just kidding. Yeah, no, yeah.
Oh, finish it off.
Over 2.
Yeah. Which, in this case, for this function, is equal to.
It's f of x. Wait, hold on.
It's 0. Yeah, because we're cubing.
Oh, I'm looking at the graph, not plugging it back in.
Okay. Well, yeah, because you look at the midpoint. Well, you get from graph too. The average of this and
It's
this.
0.
Yeah. Yeah.
So it is -1, 1. How do we know that? Why do we know it's -1, 1?
Of the f values,
Yes.
because it's this function.
No. Why? Okay, so
Those are the endpoints of the
Yeah. And because those function values differ, that's where you have a jump discontinuity.
So we're looking. The reason I'm asking because this is extended, so we're looking at the end of one boundary and the beginning of another.
Yes.
That's why it has to be extended for this type.
Well, you're extending anyway.
But I'm talking about for 19. That's why they extended
Yeah.
to see that.
Right. Yeah. To figure. Okay. Yeah. But because in this case, it turned out not to be absolutely necessary, but you got to be sure that. So what will happen is you need to take into account anywhere in the interior of the interval where there's a jump, which happened in this problem, but not in this one. And if the function values differ at the endpoints, that will also be a jump. But you don't really see that until you extend.
So, so in this case, we don't have to extend since it's already.
If you look at the formula and see they're different, that's enough. You don't have to draw the extension or anything. But yeah.
So when it's extended, it's -1 to 1 on all of it.
Yeah.
Okay. That sounds weird. I get it, but it just feels weird.
Okay. Yeah, but you're taking this portion of a graph and just replicating it. And those, the y values have to be between -1 and 1. And So these are x values though.
Yeah.
So for
Well, that's what I was saying, because you plug in f of negative 1 and f of 1, which at that point is both 1, but
yeah. So after figuring out what it is here, then that also would be extended to
I'm talking
elsewhere.
about when you plug in for the,
For this,
yes.
Yeah.
Is it always the endpoints?
the endpoints and anywhere else there's a jump in the interior of the interval, like in this homework problem, you had those jumps at like what, plus or minus a half.
Yeah, okay, so I'm trying to figure out how I word this, because the jump is at 1. That's what we're talking about. Well, it's at 1.
Yeah, there is a jump at 1, also at minus 1. In fact, there's a jump every 2.
So in the homework, would we have done f of negative 1/2 plus f of 1/2 over 2?
That's where the discontinuity happened. Yeah. Oh wait, no. Hold. No.
That's why I'm confused.
Oh, I'm sorry.
You get what I'm saying? Like the values of x that we're plugging in.
Okay, so really, this is how it happens to work out. But if I were to describe this in terms of like the theorem, really, well, the theorem is actually for a function that's already periodic and happens to have a jump. So if I do this, I can say like f of 1 plus 0 plus f of 1 minus 0 over 2. That also would work, because if I look at what's happening at x equals 1, f of 1 minus 0 is plus 1. F of 1 plus 0 is minus 1. Yeah, so really, it's you're averaging the values on either side of the jump. It's just that if you go back to the actual underlying function, those values come from x equal minus 1 and plus 1.
For the y values, the same like that.
Yeah. So no matter what kind of jump it is, an interior jump or a jump that is caused by the extension, it's always the average of the values on either side of a jump. Okay.
All right, cool.
Okay. Now, but you can't say in general if you have a Fourier function that's defined on AB, and you use a b minus a periodic extension, and if f of a is not equal to f of b, then the value of f at these x values this accounts for all boundary jumps, because if the values at the endpoints do not match, then you can take the average of them, and that'll be the value at a as well as like if k is any integer. So a, then also b, then and then the k counts for like periodic jumps, because b minus a is a period. So they're all equal to this. So this is that accounts for all boundary jumps. Interior jumps is where somewhere in the middle of this interval you have a discontinuity, and it's going to be like suppose there's a point C where it jumps. Then you have to say f of C minus 0 and C plus 0. There isn't really any other good way to express it. Okay, any questions about jump discontinuities? Yeah.
So at each point of discontinuity, the value for f of x is just equal to our a naught.
Is it equal to what?
A naught. Like if
Oh,
I,
oh, oh,
if I find
A naught in the Fourier series?
Yeah.
That's a different values because A naught turns out to be the average value of the function on the whole interval. But at a discontinuity, the value of the Fourier series is equal to the values that on either side of a jump. It's very local. Whereas A naught is like a quantity, it's like a global quantity. So the value of the Fourier series at a jump only depends on what's happening infinitesimally close to that point. Whereas A0 depends on behavior on the entire domain. So they're two different things. Now, some cases they may happen to agree. Like actually, this homework problem, they happen to agree. I think that's why I accidentally marked someone right, and I just kept going.
it was like in this one as well.
In this one also. But that's because in both cases, the function itself has a certain symmetry to it
Yeah.
that leads to that behavior. Doesn't happen in general. Yeah, so I guess we need better examples.
So for this type of problem in general, is it a good idea to drop the extension, or do we have to do that?
You don't have to draw the extension.
But it's a good idea.
Yeah, because that way you know what's what. Like you avoid overlooking in this continuity. If you don't feel like drawing it, you could also just plug the endpoints into the function, and if they don't match, you know you got one. Other discontinuities will probably come about from like you can read them off the definition of the function if it's defined piecewise.
Or if it's odd, which you should all know because that's what we taught this week.
Yeah, well, that's one, and that's a problem that I think most, if not everyone, got right. That an odd extension is generally discontinuous at 0 unless f of 0 equals 0. So yeah, odd extensions often lead to discontinuities, whereas even extensions don't. Okay. All right. Plenty of time. So other questions.
Do we need to memorize those little geometry polynomials?
Absolutely not. I will say this: whatever formulas I put on the formula sheet involving integrals in particular are needed. They're there for a reason.
Which would suggest, even though they're there, be familiar with them, use them a couple of times.
So you've already used them in your homework.
Yes.
True.
If you got
Yeah.
the homework correct.
Well, do you honestly expect me to admit that I cannot integrate?
Well, it's like the same thing over and over again. So.
Yeah. But yeah, so some practice will help your speed.
I did like extra integrating on mine that didn't even need to be done. So I could just say it was 0.
Well, there's a lot of extra integrating going on.
Yeah. It's odd, so I could just be like, no, it's 0. No, instead I integrated it and showed.
Yeah, you
I
can
know,
learn
it's
that.
good practice. I don't have to integrate that much.
Yeah, like once you finish this class, you're really ready to teach Cal too.
Yeah. Yeah, don't talk to me further. I really do got to teach another class.
Yeah, I guess I can get old after a while. But
Yeah.
I don't know.
Well, I just need something on my resume.
Yeah,
Just
yeah.
something.
Oh,
yeah, because
Working on it. This will be 2 years. So.
there's one thing I really like about 101, and I don't particularly love helping the math some because people hate it when I actually ask them to say, let's think about the mathematics here.
Oh.
They just want the answer.
yeah.
But the good thing about 101 is you really have a very good, from 101, you have a good cross-section of what a mathematical education is in Mississippi.
No, yeah.
And I think that that's a very important piece of information.
For lack thereof.
Yeah, but, let's be blunt, that's, a lot of the United States has a real problem with,
Yeah,
and it started with the introduction of new math, and it just derailed the whole system. back in the back when was that introduced? The late '60s, early '70s when they started
Oh,
that.
yeah.
I forget exactly. They abandoned it in the U.S. almost nanoseconds after they tried it
Yeah.
because they were losing math teachers left and right. But it just started a trend that I think turned what had been a pretty decent mathematical education in our public schools into something that is pretty horrific. And of course, in poorer states like Mississippi, extremely bad.
Yeah, it's rough when. So that's what comes to me. It's like, okay, now learn some advanced stuff. And like,
The part of what I'm dealing with is I'm dealing with students that just aren't comfortable with multiplication. I've had students tell me, I don't know how to do long division.
You don't have to do long division.
yeah.
No, but it's a whole lot better to know how to do long division than to have to
Is it?
type something in the calculator.
Well, they're just gonna type. I only say I've already taught these students a few times, so I already know what's coming. Like I know.
When my explanation of why synthetic division works is boiled down to the not quite correct of because the long division algorithm works.
We used to teach long division in '99, but then
So-
we don't have '99 anymore, so they just cut it out.
Yeah, I understand that but the fact is most of the kids have already seen it, but it's just, I don't know. It's good to know what people are coming at with because at the end of the day, who's going into mathematics or into the sciences? The people who, for some reason or other, got a superior mathematics education, either through their own personal initiative, through family, school. We each and every one of us in this room has a different story and a different, different
Yeah.
explanation as to what happened.
Well, I think just from observations of students over the years, a lot of it really begins at home. Like the best students seem to have that significant parental influence. That the parents take it seriously, then that's what carries over. So a problem, and then if you don't have that aspect, then it makes it a lot harder. Okay. Questions about anything else?
The L2 sequence, the space little L2.
Okay.
Will it
Oh, yes.
explicitly state big L2 or little L2?
Well, I would explicitly state, but yeah, we don't really have any problems in this test dealing with little L2.
Okay, cool.
Yeah.
But I hope we have some with big L2 in
Yes.
their product because I know how to do that quite well.
Well said.
Your wish is my command.
Yeah.
Tests have already been printed in the end of school.
Well, but yes, I read your mind in advance.
You think?
I hope that's good for everybody.
Well, we've done enough of them thus far that if we're not good with big L2, there's a bigger problem.
Cool.
Okay.
Relative error. That's probably not on there because it's homework problems.
It's not.
Homework problems. Let me go to my homework.
Well, because I pointed out which homework problems would be spotlighted.
On Monday, on Wednesday.
Yes.
Oh,
Wait, you haven't watched that yet?
I have not.
Here, I've got the numbers right here.
Well, yeah, because then I went ahead and covered new stuff. So, like, yeah, if you watch the first few minutes of that video,
Yeah.
I list homework problems and
I
examples.
can watch it.
Oh, no, you can just stop it now right now.
Okay, I'll just take a photo. Okay. Don't everybody throw their papers at me at once. She's closer.
Yeah.
Is yours nicer written?
I doubt it. I really
You know what?
doubt
To make y'all both feel good, I'm just gonna take a picture of both.
it.
Yeah, because what if a number is legible in one and not the other?
Exactly. Let's cover all the bases. So,
Okay, is this still?
well, I figured this week since I'm not getting behind on any more lectures,
Yeah.
because I'm not getting behind anymore.
Yeah.
We have our test this week, so
Oh, dang, I have to write notes this week for next week.
yeah, you do.
Oh, yeah, that sounds like fun.
I've gotten ahead, and then
So one.
Concerning the examples,
Yeah.
example 1, 11, 12, and 41, that is a issue.
Oh, yeah.
Like which chapter examples are you talking about?
Wait, example 1.41.
I think that's.
You give us exercise 0, like the exercise is repeats.
Yeah, because it's from chapter 0 or chapter 1.
And you give us a separate one that's it. Examples 1, 9, 11.
Chapter one.
Yeah, I separated by chapter.
Yeah, that goes to chapter one.
Oh, okay. That was chapter 1.
Yeah.
Alright.
Okay.
So we need to know all of these conjugate symmetry, homogeneity. Was that right?
Yeah. Like if I give a certain expression, can you show that it is or is not a valid inner product based on those properties? And there's one property in particular that tends to be the deal breaker. If it's not,
Do you care if we know the names?
I definitely do not.
I was like, I know how to do it, but I get the names.
Yeah. Yeah.
No, we have to know the names in Russian.
Sometimes I don't know the name.
Oh, and on the formula sheet, is it just negative pi to pi, or is it negative 8a from the Fourier series?
Oh, what I put in front of you was minus pi to pi.
So do we need to know negative 8a?
I don't remember.
I just don't want to forget to put the over a and the cosine because we've always worked with the 0 to 1. So
Yeah.
the 8 is really just kind of.
Let me see.
Those are the nice domains.
Yeah, it has been.
You know, it's if you get a not nice domain, I mean, the first inclination is, oh, can I translate it onto something that is a nice domain?
Yeah, the only time I say compute a Fourier series, it's on minus pi to pi.
Cool.
Okay.
All right. 1, 9. Oh, the orthogonal complement. The orthogonal complement. All right. Is that going to be on a vector, or is that going to be on like L2? Is that going to be functions?
Functions.
Functions. Okay.
Yeah, so I want you guys to understand what your orthogonal complement is. What does that mean?
That means it's perpendicular.
Yes.
Well, I mean, it would be 0. But, okay, so if I have a function, how do I find the orthogonal complement?
It consists of all functions that are orthogonal to that function in the appropriate inner product.
So I know how to do it. It's like the inner product of AB is 0 to B negative A. That thing that we talked about. The inner product of A and B with B and negative A equals 0.
You're talking about like the ordinary vectors, right?
Yes.
But here we're talking about inner product of functions, where it's the integral from A to B of like.
So that's what I'm saying. Well, the orthogonal complement was on vectors. I don't think I necessarily did that on finding it. I have proved it, whether it was or not, but not actually finding
Yeah,
it.
because there's that one problem about show that the orthogonal complement of a constant function is all functions of 0 mean.
Yes.
Yeah, that was also about orthogonal complement.
Yeah. Okay, so it's gonna be like that. Okay, so that's what.
Yes, yeah. So know that problem too.
All right. That's number 10. Okay, so y'all need to write it down.
Did I forget to mention that one?
0.
Oh, okay. It's on my list. Yeah.
Oh, it is on here. Just kidding. 1
Okay.
through 6, 10, and 13. I was looking at chapter 1. I apologize.
Okay.
That's my bad.
Okay.
All right.
Okay.
All right. So 1 through 6.
Yeah. So if you're given a function f, the orthogonal complement consists of all functions g that satisfy this. Although really I should conjugate this, but yeah.
And if I remember correctly, you had said that if you conjugated using any other book, it's F.
Yes. Yeah. These authors just wanted to mess with us, I guess.
All right. So say
So
my
it-
function was x cubed. How do I find g of t?
So there may not be an easy description of like it's a constant function. You can give an easy description, but it would be a set of all functions that such that integral of t cubed g of t
Oh.
would equal 0.
like number 10. Just forgive me.
Okay. All right.
I get what you're saying now. I get, yeah. I don't know, who am I? I get it now. Okay. I'm not, okay, yeah. Yeah, alright. Y'all have questions?
Anybody? Yeah, we still have plenty of time. 40 minutes. I mean, once all the questions are exhausted, then we're done.
Objection. So like number 16 that we had like pretty many lemmas and theorems, or we have to do something like that for,
Oh,
or is it gonna be more computational?
it's definitely more computational. I would not say entirely computational because, like, in terms of the problems and examples I gave, are about like applying certain theorems, and okay. So I would say that the test is mostly computational.
Is the projection formula on there or no?
Oh,
I don't think
no, that I did not give.
I know that.
Okay. Now, when you have a okay, I'm going to talk a little bit about orthogonal projections. All right, so given a space V, a subspace V naught, and then an orthonormal basis. Actually, I'm going to weaken that a little bit. Orthogonal basis. E1, E2, EK of V naught. So in other words, V naught, whoops. V naught is a subspace of dimension K. Then the projection of a function f onto V naught turns out to be a sum where you take these basis functions and the coefficient of Ej is given by this quotient of inner products here. Okay, so that is the formula for the orthogonal projection. Now, I was going to say orthonormal, in which case V's denominator would just be 1. But if you don't have your functions normalized, then you still need this. Now, fortunately, this becomes a lot simpler in the case when your subspace has only dimension 1. Okay, so for example, if the subspace consists of polynomials up to degree n, then your subspace has dimension n plus 1 because it's constant functions, linear functions, all the way up to degree n. Okay. So you can always compute a projection that way. That's based on.
We'll be given an orthogonal basis.
Yeah, or a little like this way. Suppose your subspace has dimension 1. Any basis I give you is orthogonal.
Oh, because it's
Because
Yeah.
these have to be orthogonal to each other, and if you only have one, then
Yeah. Right.
see, we call that vacuously true. Yeah.
Back to it.
So if my basis function only had one value in it, then I'd only be able to compute one.
There's only one term, one coefficient. Yes.
Okay. I'm sorry, y'all.
Oh no.
I'm just so animated. I don't know. I'm tired. That's why.
Well, keeps the questions coming. Then it probably helps everyone else understand.
All right, so chapter 1. So that's chapter 0.
Uh-huh.
Chapter 1, we have 9. Oh, chapter. Some of these we have done, right?
Okay. What? Make sure the list you're looking at is the right list because I get there's exercises and examples. So chapter 1, examples 9, 11, 12, and 41. Problems 19 and 33, which were assigned.
Okay, so examples with evidence.
Yeah.
I would need a book for that.
Okay.
All right, so we'll look at problems.
Okay.
19.
Well, actually, problem 19 was one we were talking about at the beginning of today about the discontinuities. Problem 33 was about.
Oh wait, that's part 3.
Yes, it is.
Oh, Parsons theorem.
Yes.
Oh. Okay. Well. Questions?
Well, actually, that's right. You worked out problem 33 already for that homework. And
Yeah.
yeah, so you're good with that one.
Yeah, I am.
Any more?
Does that help you all?
Questions? Sure. Okay.
No, definitely not. Sure.
Alright.
Don't test me.
We'll ask a question after the exam.
Now
We can, but
You're leaving though, right?
yes,
Today, tomorrow,
Wednesday,
Wednesday.
but
Coming
before,
back.
before class time.
Are you gonna be here for our meeting or no? Probably not.
No.
That's not. I just need to know.
Oh yeah.
Myself.
Yeah, maybe I forgot to mention that.
Because I'll come here and be like, where you at? But that's fine. It gives me time to study.
Okay.
We'll probably still be doing that more.
Yes, I'll be here actually right up until our meeting time of 2 o'clock. So yeah, so we're still having our meeting, which you can fill with questions if you want.
Fundamental theorem of calculus. What number is that? That's not on that number, so that's not.
Yeah, that's not going to come out.
Yeah, because that was a doozy.
Oh.
Number 32. Yeah.
Yeah,
Okay.
the infinitely many part problem.
Uh,
It's like a movie Back to School. I have one question in 27 parts.
Are we gonna do periodic extensions, or just for like the case where we're determining? Continuity?
I see. Other than that, no.
I'm looking for questions.
Okay, good. Anyone else?
Can I have a graph? Can I just like draw something cosine today?
Okay.
I like have cosine and sine like on my background on my computer, like just pulled up constantly for doing homework. Because sometimes is that not the same? Can't relate. Y'all have to check. Y'all just know.
Check what?
Sometimes I just have to see like, okay, sine is 0 here.
Oh, yeah.
So yeah. I just have to think, I mean, I know it looks like it just makes sense.
Actually, someone who to learn all the angles and so forth, and sines and cosines had him taped to her steering wheel.
Oh lordy.
Yeah.
It's still somewhat dangerous.
And now I know sine is 0 and any multiple of pi is 0.
Yep.
Boom.
So the problems, this particular problem is just going to be based on orthogonal basis.
Right.
Okay, so we don't have to.
Yeah, you don't have to. Yeah, I'm not going to make you do Graham Schmidt. Oh.
Didn't you use that or something on your problem?
Well, actually, for a previous homework problem, I just pointed you guys to Wikipedia where the answer was.
Oh, is that what we
The
would
shifted
find?
Legendre Paul? Yes.
I know that. I just knew to use Legendre polynomials.
Okay, that means we don't have to do that.
No.
Thank you.
Yeah.
Okay. So if it's from 0 to 1, that's where we put the 2 out front. 2 over A, where A is 1. We don't have PDE, so we won't talk about boundary conditions.
How will we survive without them?
That's like the last of the final.
Okay, I do have a question. On parts where we are taking like the interval of, let's say sine from negative pi to pi, do we need to explicitly state why that's 0, or
Oh,
you want me to write one note like this?
you can take that for granted. Like,
Okay.
not sure if that would really help anyway, but.
Also, is it okay to write cosine of pi x and plus cosine of negative pi x as 2 cosine of pi x?
Yes, you can.
I just want to make sure that that's cool.
Oh
I
yeah.
mean, I know they're equal to each other.
Yeah, because I mean, on a test, I have to. There's less expectation of writing out every little thing just because of time.
Ooh. Oh wait, we're not proving those ones. Well, never mind. Well, I was thinking about the absolute value of each of the IT of y equals the absolute value of cosine t plus I sine t.
Oh.
So I did it differently, but that was we needed to use the square both sides.
Oh, for which thing?
It was one of the lemma 16. That's not even a problem. I was just looking through.
Yeah,
Like, square both sides to show that these are equal to each other, equal to 1.
Oh.
I should have proved that was equal to 1, but you said to do that instead of.
Yeah. So automatically squaring both sides is not what. Oh, it was squaring both sides of that. Yes. Right. Yeah.
Okay.
Or. Yeah, just because it's a simple formula for absolute value squared. It's real part squared versus imaginary part squared. But yeah, we're not. There's nothing like that.
I'm confused. I was looking back to look at the examples and stuff in my book, and I was looking for example 1 in chapter 1. So, am I crazy or is it not? It jumped straight to example 1.5.
Oh, okay. Why? Example 1 is not on my list.
For chapter 1?
You guys got to keep straight exercises versus.
Okay, I wrote it down as an example. Sorry.
Okay. Well, okay. I'm just gonna repeat
I
this.
think that means that's not the number. Oh wait, that's not yours. That was chapter 1. 1 point. 9, 11, 12, and 41. That's what happened.
Yeah, but I used to just identify. But yeah, chapter dot whatever.
This is why I took 2 photos.
just to make absolute actually from chapter 0 there are only 1, 3, 6, 10, and 13. Okay, and then from chapter, and then 11, 12, 41. 9, 11, 12, 41, and exercises 19 and 33. Okay. Okay, who's airdropping?
Did you get something?
No, just an assignment.
Okay. Is that a homework revision?
Yeah, the 19, the latter parts.
Okay.
18.
All right. Well, we still have 20 something minutes for any further questions. Or if you're not sure, you can email me later.
Send you frantic emails in the middle of the night.
Well, I just
They'll
talked
probably answer.
up to a point, yes.
Yeah.
Well, I've discovered that the best time for me to get a response and then respond back is at 2 o'clock in the morning.
Less so lately. But
That's
yeah.
so late.
It's just a little bit, but yeah.
We're putting prompt. He's putting prompt.
Yeah.
For responding. I appreciate it. I'm
You
emailing
inspired
at like
us.
7:30 Sunday morning. Help! I'm stuck on this problem.
Inspired us to want to respond to our students.
Yeah.
Oh, well, good.
But there's never like questions about homework. It's like, hey, so last week I just didn't get around to doing the homework. So like, could you open it for me again?
My grandfather died.
That's that is.
Yeah.
My grandfather died.
Yeah.
Well, what I don't understand is like the professors that just don't bother answering student emails, because those are the easiest ones to answer.
Yeah.
It's once they get from anyone else, they're like, I don't know what to do this.
I will say that was hard for me when a student told me somebody had passed away and they needed an excuse, and then I had to ask for documentation. So then they sent me the obituary, and yeah, that was kind of not something I really wanted to see, actually, because it was a young kid, and I was like, I have a hard time asking for it when they talk about a death. Like some girl just said her little cousin died from leukemia. I really don't want to ask for a death certificate for that. I don't know. Or not or obituary or whatever.
We've had one say, what's grandfather died?
Yeah, grandfather.
Yeah. Pulled that same study 2 different times in 2 different classes.
Oh.
So it was like,
It's all about cost benefit, you know. The point is, if somebody's going to be such a scumbag as to do it over a quiz, you know, one of how many I don't know how many 14 quizzes that are only 5% of the course.
Hey, I'll give
They're
y'all a tip too.
foolish. Yeah.
That I didn't think that I didn't do my first semester, but Emily told me people that miss assignments, I will not open a quiz up until they complete the homework for full half credit or whatever.
Mhm.
Because if you just open the assignments for them, half the time they won't even go take them. So if they finish the homework and then email you, then you go open the assignments. So you don't waste your time. Because half the time they don't even finish the homework assignment to get the quiz open. Saves you work.
That doesn't sound like a good idea.
Yeah, right.
Let me guess what their average in course is.
well, it hasn't updated because they're still locked out.
Well, let me guess what the average was before it got locked out.
Actually, some students with some pretty good averages.
Yeah,
that haven't
that's what I was
lost
gonna say. I mean, she was passing.
Like they have B's.
Oh, the only students that haven't bought the access code from me were
I feel bad for our
we're
students.
solid
They're
F,
having a rough
and
couple
the
weeks.
kind of F that I wonder if
The whole
really
time,
worth their
y'all
time
make
and money to
schedules
continue.
and
Yeah.
When somebody's average is a 30 in the class, at this point, you kind of have to wonder if it's going to correct.
Yeah, and you'd think they withdraw, but then some just stick around.
Yeah.
They stick around for that new financial aid. You gotta have 15 hours, so if they drop, they'll lose their financial aid.
Oh, that's why.
So it's better for them to stay in the class, you can fail, than it is to drop it.
Yeah.
That's what happens.
Yep.
Okay.
Well, I definitely have a few people that have that mentality.
Yeah, something that hurts our failure rate, and
Yep.
artificially so.
Well, it's all about trying to battle competing interests.
Yeah. Well, any other questions? No, I think we're good for now.
How many questions is it?
There are 6 problems.
Six problems. 6 problems. Hour.
But you have an hour and a half period.
Okay.
Assuming Dr. Juice shows up on time. Which is better. Also, I can see his class until like 2:55 here in this building. Okay, but there's really no excuse.
We'll drag it.
Okay.
Like-
Well,
like
all you
it's
need to
with
drag
all,
yourselves in
right?
here.
Like y'all just literally have to just bring it with you
Yeah.
in the classroom. Okay.
So we're talking about 15 minutes.
Do you want to see that too?
Yeah, exactly.
So that means we should definitely practice to being able to do it 10 minutes a problem just in case.
Yeah, something like that.
We're all gonna make 100, right, guys?
Well, I'm going to do my best.
Today. I don't know, but the grading system in grad school just scares me. Because you gotta have above a 95 to get to keep your 4.0, and that oh
Oh, because the whole A- thing.
yes, it
Yeah,
makes me
I
cringe.
don't do that.
Oh really?
No.
You just do A?
Yeah, and the reason why it's a protest because they have no A+. Okay, in some rare cases they give an A-, but I try not to. But
Okay, it makes me feel better.
yeah.
I'm like over here struggling, like I gotta have above a 95.
Really, I give it A- when I might normally give a B.
Okay. Okay.
And what's the average you keep to not get like kicked out?
You just don't need to get a C.
Yeah.
What is it? You have to have a 3.5 to get into the PhD program. Yeah. I'm just saying that if you wanted to go on, you gotta have a 3.5 to get in. I'm done.
Okay, well.
It's a lifestyle. Just a professional student.
Oh, yeah, sorry, I forgot I'd given some A- in the Python class. Okay. Yeah, that was an exception.
I did a lot of work for that Python.
Was it a lot of work?
Oh, actually, yeah, because I gave A-, I end up, everybody got at least an A-. Yeah.
Oh, so nobody got. So those were the people that probably should have had a B. No,
Or-
I'm sorry. Not like
Or
bad.
I'd say a harsher instructor might have given a B.
Okay.
Yeah, because the grade should be a little bit lower, but yeah, but still good. Okay. Well, if you got nothing else, then I guess we call it a day. All right. But yeah, certainly you can ask questions in the meantime.
Alright, so you still got a question?
Yeah.
Outside.